Hi, this is Dr. S and this is video 14 of my series on aromatic chemistry for OCR A-level. This video is about activating and deactivating groups. So in the last video, we looked at the difference between the reactivity of phenol compared to benzene. Just to remind us, benzene is actually quite unreactive when it comes to electrophilic substitution. So if we added bromine to it, it would not react unless we had a halogen carrier to catalyse the reaction. But if we put an OH group and turn it into a phenol, then it will react without the need for a halogen carrier to make 2,4,6 tribromo phenol and 3HBr, 3Br2s. Okay, we went through the reason why that happens more readily, and just to remind us, this was the summary slide that I put up. Phenol is more reactive than benzene because there's a lone pair of electrons on the oxygen which delocalizes into the ring, increasing the electron density of the ring, so it can then polarize the bromine molecule. So we call the phenol group an activating group. It is making the aromatic ring more reactive. There are a few activating and deactivating groups that you should be aware of. Another activating group is this group. Now you won't have seen this yet. It's called the amine group, the NH2, but for a similar reason, that is also an activating group. There's a lone pair on the nitrogen which can delocalize into the ring just like the OH did. So the same sort of reaction will happen, and you will not need a halogen carrier in order to react bromine with aminobenzene. So they are the two common activating groups that you need to be aware of. Okay, so let's try and make a list of the activating and deactivating groups that you should be aware of. So activating, remember these are ones that make the benzene ring more reactive, would be the OH and the NH2. Now they are the two that you need for the A level, but there are also a couple more that you may see, but they won't necessarily expect you to remember. Okay, so they would be something like this, where the R group is a carbon chain. All that. So to give you an example of some of these structures, it might be a benzene ring with an oxygen directly attached and then a methyl group or an ethyl group or something like that. Whereas the one with just the R is then just a carbon chain directly attached to the aromatic ring. Now what you'll see in common between these three activating groups is that there's a lone pair on the atom that's directly attached to the ring, which means that there's more electrons which can delocalize it into the ring. This one's slightly different. This is a different mechanism by which it makes it more reactive, which is beyond the A level. It's called the inductive effect. So that is a slight activator, which is why you probably won't see it in the A level. But if they do, they will tell you it's an activating group. Okay, on the other side, let's look at deactivating groups. Now, as you might be able to suggest, deactivating groups make the benzene ring less reactive. And the really common one that you need to know for the A level is the nitro group. So we've seen nitrobenzenes before. Something like this. They are less likely to react through electrophilic substitution than benzene would be itself. So you really have to push these in order to add something else to that ring. So you'd need to use a halogen carrier, you'd need to use really extreme conditions, something to force the reaction to happen. So it's making it less reactive. As I said, that's the one you need for the A level, but other ones that you might see would be a carboxylic acid group directly attached to the benzene ring, so something like this. Now we've seen this one before, this is called benzoic acid. You might have what we call a nitrile group, again you'll see that later on in the specification, so it'll just look like that. Or you might have something like an aldehyde directly attached. Something like that. Now if we look for the common features between these four deactivating groups, then if you look for the electronegative atoms, The most electronegative atom in this bit here is the oxygen. So what that's doing is it's pulling electrons away from the nitrogen, which in turn means that some of the electrons are pulled away from this ring. Same thing here. Where are the electronegative groups? They're 2 atoms away. So the oxygens are pulling electrons from the carbon, which is in turn pulling electrons out the ring. Same thing here. This is the strongly electronegative one. It's 2 bonds away. And here it's oxygen 2 bonds away. So these are the common features in deactivating groups that make them, the structures, less reactive. Okay? But remember, it's only the 3 in orange that you need for the OCR A level. Okay, in the next video, we're going to look at how these then control the position of substitution. So how they direct where the next thing to attach to the ring will go. And we've seen a hint towards that in some of our previous videos. So I will see you then.